because we're adding a third variable, your regular mode can't handle a third variable. It can only handle your x and your y, like your time and your height. The third variable is what we're going to put in your parametrics. So if you go to mode, you're going to hit the mode button. You're going to come down here off of function and you're going to hit PAR. This is your parametrics. What it also does when you watch this, it graphs something that's not a function. A function is the only thing we can graph because it has to have, every x has to have a unique y. But in parametrics, you're going to actually watch the thing circle through. So we're going to go to parametrics. Now hit your y equals. See what it's giving you? It's giving you two sets of equations over t, over time. It's giving you your x equation, it's giving you your y equation. So if you take a look at, guys, if you take a look at this, the one that we're going to graph, in your x, you're going to put t squared minus 4. As soon as you hit this x button, to see where it says xt, theta n, as soon as you hit this in parametric mode, you get a t. So we're going to put this in, t squared minus 4. Every parametric needs two sets of equations. And then in this one, we're going to put t divided by 2. Wednesday, we're going to take these and do them algebraically. We're going to eliminate one variable and make one set of what we call a rectangular equation. Now, we're going to graph this thing. But we're going to have a little bit of a problem when we graph this. So we have to go to your window. We've got to set your minimum and your maximum values for your t. Now what happens when we do this is your t-step is important, but your t-step is something that's going to change a little bit. Your t-step is going to tell it, is it smooth, is it not smooth? The t-step we generally have to play with a little bit. Now, notice the restriction on the domain says from -2, from -2 to positive 3. We're going from -2 to positive 3. We want to graph just this piece. So we're going to have to change your table a little bit. And we want to look at where the orientation comes from. What's going on with my calculator? Giving me what I want to say. Did you all get what I got, or did you get another line underneath it? You got the same thing I got? Okay. All right, let's go change your window and change your t-step. You're going to have to change your t minimum to -2. And your t maximum is going to be 3. We got to, because we have a restricted domain here. Now, leave your t-step to this. Leave it to 0.1 right now. And leave everything else the way it is. And graph. Did you see it change? Did you see what happened here? For you to see it again, you got to change something. If you just hit graph, it's just going to show the same graph again. But say I go in and I just change my t-step. Watch my t-step. I'm changing it to 0.3. Okay. It goes a little bit slower, probably not much that you would notice. I'm going to change my t-step again to 1. Still a little bit slower, but do you see how it's not as smooth? I'm going to change my t-step to 2. And it kind of stopped. See, it's kind of a little strange looking. Your t-step has a lot to do with this. Most of the time we leave it small. And this is the only time this will graph something that's not a function. Notice this is not a function. Whenever you went to graph a circle, you had to put 2 equations in. You had to put the positive part, you had to put the negative part. This will graph a graph that's not a function. And it graphs it over time. And if you notice, its starting point was right here. And then it went, I don't know if you saw it go, and then it went here, here, here. This is called the orientation. How it, if we trace its movement from the beginning to the end. And all we're doing is looking in those, just this little window from -2 to +3, just to see where this is moving. And we follow its orientation. So if you started with zeros, and if you look at your table, let me just erase this mess. These are the actual points that you're graphing in here. These are your actual XY points that you're graphing. So if you looked at your table or you want to make this graph, these are the points that you're going to graph. It's over time. There's our third parameter, over time, but it's still giving us an X and Y point. So if we take this, and if we put this in your table, let's make a little table so that you can kind of see it all. Once we do something that's a little bit more recognizable, it'll probably make more sense. But let's take your table. Here's your T, here's your X, here's your Y. We're going to just use this domain. Okay, and we're just going to record those points. And now we're going to sketch this. And remember, we're just sketching these points. We're still in an XY plane. So these are your XY points. Our third parameter is kind of like unseen to us. It's the one that actually runs that graph, that makes it go. But it doesn't chart on our graphs. We're still an XY point. It's a little bit of a different concept. So if we took this guy and we graphed these points, watch where these fall. I'm just going to put tick marks in here right now so you can kind of see them. At the 0, this is where we started. At the 0, we were -1. At the -3, we were -0.5. At the -4, we were 0. At the -3, we were +0.5. See it coming up? At the 0, we were 1. And at the 5, we are 1.5. I don't know if you saw that bar. See it go? Here's where it started, right here. This was its beginning. So its orientation is this. It's going this way. We can graph circles. We're going to be graphing circles like this. We're going to be graphing lots of things like this. There's a really, really cool example that we graph a Ferris wheel, the motion like this of a circle, and somebody throwing something onto the Ferris wheel. So you actually see the thing going that 2 times. You see your Ferris wheel moving, and you see the person throwing it, and you see where it hits your Ferris wheel. So that's a pretty cool problem to do. We have to set, we'll set something like that up when we work on applications. But right now, I just want you to get the concept of this third variable. It's a little bit of an abstract concept because you don't see it on your graph. What this is the movement of time. As time goes, it's moving in XY coordinates. Does that kind of make any sense? You see it much, much better when we do applications. So unfortunately, we kind of have to go through this before we get to the application part. Okay? So here's another one I want you to graph. We're going to put this in your calculator. Here's a quadratic function and a cubic function. Whoops. So we're going to go to your y equals. We're going to clear these guys out. we're going to put in, don't forget when you hit T in parametric mode, when you hit the X, you'll get the T. It works the same way as an X does. And we're going to raise this guy to the third.
You don't make points for these, right? You want to grab like a...
Well, I want you to make a table. Right now, I'm giving you the domains right now. This is a restricted domain that I want you to use.
Or like normal language is sketchy.
Well, kind of. Like when we do something with a circle or an ellipse, we actually use angles. So we'll have to set our angles to that. And we'll get to that Wednesday. I'll get to that. I just wanted to show you a basic parametric graph. So now, when you graph this, see how it looks a little weird? It should come off the 0, 0, but it's not. So what we're going to do is change your T-step. Maybe I need to make this a little smaller, so it's a little smoother. Maybe I need to make it a little bit larger. See, it came closer to the 0, 0. See what your T-step did? T-step is time. Like, where should I move my T-step to? Usually, 1 is a good place to start, unless the numbers are really, really small. If I go a little higher, it probably isn't look a little bit better. Do you see it now? A little better. Do you see it change from when it's small and it's usually it's like not as smooth when you get there. So you have to kind of smooth it out a little bit. Again, just so that you get used to this. This is your third parameter, time. And I want you to use this domain. I want you to write these down because these are the points I want you to look at. Your X, Y points. That's the point that we actually graph to get this. Now the orientation on this, we'll be able to see your orientation when we graph it ourselves, but your orientation on this started here and went like this. Okay? You'd never be able to graph that in a regular coordinate plane. You can't graph something that's not a function. Parametrics allow us to graph something that's not a function. So if we write these down, granted we're not going to graph all these points, probably starting at the -2, but I want you to see these points. And you can see the symmetry in your chart as well. God bless you. See your symmetry in your graph? When we do this, this is your XY point. You see your XY points. You could see it turn. There's its turning point at the 0, 0. You see your symmetry here? It allows you to graph this over time. And time is more of the abstract point right now. So we're still graphing an XY point. We still have a regular coordinate plane. But we give it a third variable. That's kind of like, we don't really see it on our graph, but we know it's there because we can watch it move. We can watch the time change. When we get to an application, this will totally make a lot more sense. And as soon as we hit Wednesday, when we actually do these algebraically, when we eliminate these parameters, algebraically, you're going to see, if we eliminate this from one to the other, how different it is. Okay? And I just want you to get used to like graphing with these. Right. Again, you're going to change your mode. You're going to make sure your mode is in parametrics. And key to this is your table. This is where I restricted everything. And I think even on your homework, it's all restricted. Yeah, it's from -5 to +5 on your homework. So you're just going to look at your table from -5 to +5. You're going to put it in your calculator, and you're just going to sketch me that. So if I sketch this, I can't really do these too much, but my 4 is -8, my 1 is -1, my 0, 0, my 1, 1, my 4. Do you see the pattern here? This is where it's going. That's where it's going. Just so that you get a good feel for the sketch. And that time is the abstract one. This is moving over time. That's what we're moving. That's what's making us move, the third parameter. But we're still sketching an X and a Y on this graph. When we do a little bit more with this on Wednesday or tomorrow, based on how many of you guys show up, I won't, here's my